Hey guys, how's it going? Welcome to another episode of Ferris Makes Demos. This is episode 52, entitled Botch. And I'll get into why that is in a second. First, a little bit of history. So, the demo tool that I have is called Demotivation. Been working on it for a little over 3 years now. I started it in March of 2016, I believe. And it took until October that year before we did a 64K with it. One of the core ideas that came into the tool around July of that year, or I believe that's when I started working on it. I think it started working a little bit later than that, is this operator grid. So let me pull this up. I'll just pull up Dope on Wax, which won't work because my sync tracker is not running. Going a little slow today because I feel like it. That's great, YX. And totally not what I would have said at all. Okay. This is demotivation. Hooks up to Rocket, does some things. The main thing that I want to talk about today is this operator grid. And essentially what this is, I mentioned this a few times, but this is like a visual programming language. There's a few basic parts to this. I know it's a little small because that's just how it is. I haven't implemented Zoom for this, so just deal with it. But if we just look at these operators, in fact, I'll actually just dock it down here and make it real big. No one needs preview, no one needs the profiler. The main idea is that each one of these little stacks here sort of represents a scope. And in fact, each one of these operators is actually its own scope. So a big stack like this actually has, each one of these is its own scope in like AST form. So rather than it being like a stack and then you have all the children like this, it's actually that it's like a deep tree. Each operator is another node and their children of that node rather than like an order list of children. I do have plans at some point to make it so that you can make the operators wider than like one grid position, and then you can have several stacks underneath, and that will fan out like this, but I just haven't done that. So everything works like this. The one exception to that rule is, of course, that this supports subroutines, which is what these SB ones are, and then you can see CL for calling. And that's actually the mechanism I use to sort of simulate this right now, which is kind of why I haven't implemented it. Essentially, the data structure internally is just a hash map from position to operator. So if I were to add like operator width, I'd have to complex that a little bit, and I just don't want to do that. Keeps things very, very simple. Anyway, the operators here, there's some are conditionals. So you evaluate an expression. If that's, I think, greater than or equal to 0, then you evaluate the child scopes. Otherwise, you don't. There's things like loading a mesh, calling a subroutine, as I mentioned, changing depth mask, and of course, things that change OpenGL state like this are scoped. That's why that scoping is so important, because like this depth mask will then only be changed within this bottom scope here. Things like draw a primitive, set some uniforms, bind a program. There's a concept of variables. So there's a big variable store, and you can set locals, which will take a variable and push it on the stack and then overwrite the value and then pop it at the end of the scope. There's globals, which do the same thing, but they don't push and pop the value, so it doesn't preserve the value. So like if you want a scoped variable, you can do like a local, and then underneath you can do globals to change that state, and then out when it comes out of that local scope, it'll be preserved. There's a little bit of a random number generator that you can seed, and then you can use these random expressions here. So that's another thing, is that all these operators have like a type, and then they have various expressions depending on what kind of operator it is. So for example, this is a local operator, and it has a name of the local variable that you're doing. The value in this case is a rotation matrix about the y-axis with this many radians, I think, times the current world matrix, and then the data type is mat4. I think there's only 2 data types in this grid right now, which is f64 and mat4. Those are self-explanatory. Other than that, I guess it's pretty straightforward. There's just a lot more kind of operators I didn't really talk about. But the big advantage of this is that this gets compiled to x86. So first of all, it gets compiled to a bytecode. And then the bytecode is actually what we ship in the intros. And both the intro and the tool also have a JIT compiler, which will convert that into x86. And that conversion is pretty basic because the bytecode is like linear. So other than the conditionals with if, and then there's a repeat operator as well, which will repeat a number of times this expression. Other than those two, it's really straightforward because it's just like the operator will map to a function call or it'll map to some really basic stuff. The conditionals are almost as simple, except they need to keep track of some state in order to, they have to do some fix-ups in the generated x86 later, because like you need to do like a conditional and then the code inside the conditional, and then you need to rewrite the code here to say like if the conditional wasn't taken, or if that branch, or I guess if you need to branch over the code, then you need to fix up the address to do that. That, and then of course subroutines, which is, as I said, the exception to like the scoping. And essentially each subroutine has its own little scope like that. And then there's a lot of like checks here. Like if I try to put a subroutine beneath some other stuff, that'll be an error. If I call a subroutine that doesn't exist, that'll be an error. Stuff like bad type, hi, doesn't work. Stuff like that. And then you can just move these around, etc., etc. The compilation for this, the first thing it actually does is it transforms it from this grid representation into an AST that actually looks like this. And as it's doing that, we'll also parse several of the instructions, or I mean, the expressions. For example, like values get parsed to a little expression tree, like a typed expression AST. And then of course, like the matrix or the number type is actually known already at that stage. So we actually use that to parse that as well. Lots of kind of cool stuff. But yeah, this operator grid is really nice to be able to change all of the CPU code in the intro on the fly. In fact, we implement our entire renderer within this, and of course all the shaders it comes with. So this is the rendering pipeline. Set up some globals for that, gbuffer pass. I think this is light accumulation pass, light composite pass, which I think doesn't actually traverse the scene. These two will traverse the scene, and then this one will just accumulate all the lights. Some SSR stuff. There's some depth of field stuff, some bloom stuff, compositing all that together. I have another pass where it traverses into the scene again in case there's any like stuff that the scene wants to draw on top of this. Does some masking, aberration. And then this is, I think, tone map and gamma, and then FXA in this case. The point is that all of this can be changed, and it can be changed live. So like if I want to, I don't know, something really easy would be like if I want to not output the tone map and gamma target to the FXA pass, I can do like the masking target. And this is the output of a different pass. And it's nice to be able to just sort of change anything in this. And generally, I'm actually really happy with sort of the level of abstraction in terms of having sort of a playground to change OpenGL code. I actually really like this. However, the big problem, and I've been feeling this for a while, and I knew I kind of wanted to start building on top of this a little more, but it took me a long time to really figure out the way I want to do it. But the big problem is that this doesn't work that well when we want to start composing like higher level scenes. So for example, this is like, as you can see, first of all, the stacks get kind of large in these groups of them, especially with this renderer in particular, like, let's see, where is this? This is tubes, I think it's called. Tube logo. So this is the grid for this particular scene. It's actually not that much. There's the shader stuff for the light map and the gbuffer pass. I say light map, but I really should say shadow map. And then, yeah, so like this is the main one. We check that this is the right scene in the tracker. This is the background gradient. And if I just like disconnect this, then this stuff doesn't get parsed. That's why that goes away. The subject, which I think is the actual tubes. And there's stuff like I can change the number of tubes here. 200, stuff like that. all the variables. I can change some of the material parameters, but I think that actually comes from the shader in this case. Turn off the lights by just removing them. All the stuff. This little end map that's hacky and shitty. Background objects. Anyway, like, my point here is that I'm trying to get to is that, like, this, the render is set up so that most of the things that are there, like, you make a scene function and then you call some other functions. And when you call a function, the way you pass arguments is you just set locals that have names of arguments. And then the subroutine will make sure they have these argument parameters, which will make sure that as you're compiling, it keeps track of what locals are available in that scope. And it makes sure that for every scope that this subroutine is called in, that there are locals of the same name in the calling scope or somewhere above that. In order to make that work out. And that's really nice, but it's annoying when you want to do like change the spotlight color, because I have to go in here and then change the red component and then go in here and change the green component. Like, I don't have color pickers, for example. And like color pickers or gizmos to move things around. I do have some mouse control here that I can like map to a camera. So like if I put this back in, I can like move around. But ultimately I just need to build some sort of like higher level tooling. And I think like there's a lot of ways that I could go about this. I've been thinking it like basically in my head for the last couple of years about different ways I can do this. For example, if I wanted a color picker, I could just as well make like a color picker operator that will set 3 locals. Like you could have like a prefix for the name, and then it will set like red, green, and blue. And then you get a color picker when you click on this instead of just these text fields. I have thought about things like I have expressions for like grabbing something from the sync tracker. I have expressions for grabbing stuff from like a MIDI controller as well for when we do our live sets. And I might as well, I could introduce one that will say like, give me a macro panel that will have a color picker in it, and then I'll grab the thing from there. And then it would maybe show panels over here. So you can kind of build those higher level structures just by virtue of what you use in this graph. That was an idea that I had for a long time. But I think actually, especially after building this renderer, like most of these stuff are encapsulated by, for example, setting a bunch of locals and then doing a function call. And even if I did all that higher level stuff in this operator grid, I think it's still like too much scrolling around when I need to find stuff. Like these are just too heavy. So I guess the thing that I'm trying to get at is that ultimately I want something a little different than that. And the design that I came up with is actually super general, and I'm really excited about it. Surprise, surprise, it's called Botch. And that's a direct wordplay on notch. What I want to do is I want to have nodes. So you'd have some nodes here that are connected noodle fashion, however that may look. And I want to actually compile these down to the operators. But the key here that's actually really important and that I think is really clever is that I want that, like the definitions of the nodes themselves and the way that they're compiled to operate to like subgraphs in this operator grid. I need that to be entirely up to the project itself. So the reason I want to do that is because I want to be able to say, like, in this particular demo, we have this sort of wax scene that's at the end here. And the content in this case isn't an actual like fluid or anything. It's just an SDF. And the components that build up that SDF are really simple. But in order to be able to build like nodes that would have generated that SDF code, which is what ultimately I would like, then I would need a way to be able to specify, okay, here's a set of nodes that will compile to some shader code or compile to a certain operators, certain stack of operators. And here's the way that gets compiled as part of my project, like specifically for this one effect. And then maybe I can reuse some of those SDF nodes in another project for a different purpose. But essentially, I want that ability, the ability to like make an effect and make custom nodes for it and expose that however I want without restarting the tool and without having to change any of the tool code and have everything just kind of work out. So I need that compilation to be part of the project. And so the way I've been thinking about doing that is I want sort of 3 separate parts. We'll get to that in a sec. But essentially, no, there we go. I need some kind of node model. And this will consist of a couple things. So there's like an editor, or there's sort of basic node properties. So a node has a name, and it has a position, and it has different things it's connected to, and it has different properties. And those might be exposed different ways. I need the node compilation. And then this is like, how do I turn nodes into operators or something like that? And then I need the UI for the nodes. And what I'm thinking is that the UI should actually be entirely agnostic of this other stuff. It should, from the node model, be able to understand just enough about like the types of nodes and how they might be able to connect, and be able to specify a couple like subtypes, things like that, or new types that can be aggregates of like properties and things like that. And it should be able to do some basic checking to make sure that a given set of nodes and connections actually makes sense. It needs to be really permissive because we can change whether or not stuff makes sense on the fly. So it needs to be able to handle the fact that there might actually be invalid connections, but it should tell the user that. And I think that we can do a lot of checking on this level before we do any of the dynamic compilation stuff. So I'm thinking the node model needs to be really general, but I think that actually wouldn't be that difficult. And then for compilation, what I want to do is I want to take the node model and sort of flatten it to sort of an AST-like thing. And then I actually want to give that to a Lua interpreter. And I want everything to happen in Lua after that, almost. So this entire thing where we take this sort of flattened graph and translate it into operators, or something like operators. I might go to the AST that comes after the operators so that I can potentially report errors a little bit better. But I'm thinking I do all of that in Lua, and then I pull the resulting operators out of that, combine that with what's in the actual operator grid in the tool, and compile all that together as I normally would. That's roughly what I'm thinking. And I've done some prototyping with this, not for the UI yet, but just for like the data structures. And I think that this will actually work extremely well. Another source of inspiration for this is obviously Notch. I've been watching a couple tutorials for the nodes that they have and the properties there. And it looks pretty good. I'm just going to check out that link that you posted. Oh, that's who made that. I never noticed who made that, Daniel Collin. I don't actually know that person, but I guess I've seen them around on the GameStack Slack. So yeah, I might be able to do something off the shelf for the actual UI part of it. Especially because I'm just thinking like the nodes themselves are going to be super general. But there is a fair amount of stuff to build here. And we got to start somewhere. But does that make sense to you guys? Now, I won't have the make awesome demo button, but it'll get it. We might be able to make that button with the nodes. Yeah, I'm not a huge fan of Lua either, but it's extremely easy to embed, and I've already embedded it in Rust using RLua, which seems to be really good. And it should just have everything I need, which is some basic way of having objects, some basic traversal of those objects, and some string manipulation. And there really isn't much more that I should actually need, because I'm thinking that most of the compilation for a node is just going to be like, make a new subroutine, fill in all of these operators, and then call something else. And that's mostly what you do. And then for the different parameters here, you just pass on strings from the node properties. So it should actually be really good, and it should be fast enough to run this. So basically, whenever I change one of these, or in the case of what I'll end up with, whenever I change like a slider value, I'll be recompiling the entire thing and going through Lua. And I actually think it'll be totally fine. And the German, yeah, but I don't need a lot of like complex manipulation either. Like I don't think I'll ever need to parse them more than like looking for commas or something. And I might be wrong about all this, but I'm thinking that this will all work out really well, actually. Another alternative to Lua would be Gluon, which I also looked into, but I decided that I actually don't want a functional language for this. I actually think I could make like a really appropriate DSL within that would make compilation really easy. But I think if I'm going to have this as our group's demo tool, one of the really important things here is that like Hoffman or Wobble can go in and just like edit some of the node definitions if they want to expose a new parameter or something. And for that, I want the language to be as consistent with the other languages that we use in the tool as possible. especially GLSL, because that's what will end up doing most of the actual code per intro in. So I think that makes sense. I would say I handled that quickly. I probably mumbled my way through it, but I think we got there. By the way, how do you guys in the chat? Zokwar, CPDT, Luna, Dark Second, Max Low, Sandals, Chief Detector, Aaron the German, Pedoroya. Yes, still using a new rocket. I did start my own sequencer a couple times. And just never was motivated to get that far with it. And then by the time we start doing a demo, I just don't care anymore, and we just use rocket. Daniel Collin. I think that's everyone already. Yeah, Max though. So I auto host a couple people. You can do that on Twitch, where you just like host someone else's channel. So whenever you're not streaming, then someone else can be exposed to your followers, I guess. Yeah. So far the tests I've done, I'll just show a little bit of this. This is my little test bed here. And I haven't really gotten very far here. I've just, like, I made a main, and I've made a Lua context, and I've just made some nodes here, which I haven't, like, dropped this to, like, the AST form. And then... Oh, really, Maxlo? Like, you were still seeing him for that long? Now, my stream started 20 minutes ago. It was a little late, but anyway. Yes, Testy Boy, another boy. Get used to that. But anyway, I just wanted to like put these into Lua, which is pretty easy to do. Run some Lua to compile it, and then pull them out of Lua again. And that works really well, especially pulling these operators out of this. This actually doesn't use these input objects right now, just because I'm just throwing stuff together. So like this was the first test of like reading that out in Lua. Some stuff. And I'm thinking most of this too will end up as like this prologue that's just kind of always loaded. And then whenever the recompile needs to happen, if we need to, we'll reload the actual compile function. Otherwise we won't. And then we'll just call that. Should be pretty basic. Anyway, in this case, I made like a node and then I compiled it. And then I set the output to this operators thing and then pulled the actual stuff out. So I'm thinking that most of the code will end up looking something like this. Start a subroutine and then just call these functions that represent specific operators that you want, and like sort of the connecting them and putting them in stacks is just kind of done behind the scenes for you here. And then you'll end a subroutine. So like this is generally what you would do. I think the main use cases for this, as demonstrated here, the first place that this will actually be employed, and probably where it's going to most be used, is in just like putting objects together to make a scene. Because again, actually, where is this? Let's go to, not Bandicles. I think it's Wax, which is here. So for example, making this scene, like this is the 3 lights in the scene, and this takes up way too much screen real estate. Whereas each one of these could be an individual node that were just connected to some route. And then all of this would be compiled to exactly these 3 subroutines. So this is subroutine, and then put a bunch of locals down, basically forwarding the string parameters from the nodes to the operators, and then making this function call to call light. And that's how a light node would be compiled, or a spotlight node in this case. And that's it. Like that should be trivial to describe in Lua, and that's like 90% of what we're doing here because of the way that the render is built. So I would still have the render as this operator graph, and I would still do everything like low level in that, but then I would assume that the function called scene is compiled from this node graph that would assemble a bunch of scenes or objects into a scene. And everything should be compiled together, and it should all just work. Dan Collins says, I guess Lua is only used for the tool. Yes, exactly. So Lua is only used like while we're authoring stuff to compile the higher level nodes to these operators. And then the compilation after that, which goes to the bytecode and everything, is exactly the same. That doesn't change at all. So that should make it really good. So this doesn't affect any of the output, doesn't affect any of the runtime, except I will add probably a couple more expressions, maybe a couple operators that will like accept raw strings rather than just files. For example, generating shader code. Because I think too, like I can have operators like right now when we bind a program, you have to specify file names for like the vert, the geometry, and the fragment shader. Whereas if these were, for example, lists, so like all the files were prefixed with like file colon, and then I could also have like comma separated lists for like chunks that could be put together. Then I could actually very easily inject code into this, where I would have the Lua code just generate this string for what this would be. And then it's very small strings that it's putting together. But again, I can have like a generated SDF as part of that, part of the value for this operator. And then the compiler beneath that would just take care of the rest. There's a lot of potential for screwing things up here. But I think this will work really well. I think it'll work really well. Yeah, I considered having my own DSL for this too. But ultimately, as we discussed at the airport CPT, very quickly, you run into cases where like you actually want full flow control, or the ability to like build a context object and have different nodes just like affect that and then defer some compilation until after all that stuff's done once you've collected all that information. Like there's a lot of those kind of patterns that you have when compiling things. So the 90% of the time, yes, it's like super trivial what you're actually doing, but yeah. So I didn't feel like implementing another DSL, but we probably will have some kind of DSL or UI for making the node definitions. And I'm not sure what that's going to look like right now. So what I'm thinking is for like an MVP, I just kind of actually put the full node model into Lua and have that compile everything into operators and then pull that out, because that'll be sort of the shortest path to getting something working, because then we can make a UI that very trivially hooks stuff up. And in fact, for the very early tests, I'm just going to have nodes that I probably write in XML and I don't have a UI for it. But I'm able to like throw that together really quickly and have it go through the entire pipeline. Because one of the earliest things I did in this tool is if I do Control R, it will actually reload the project. It actually takes a second there because I think it reloads assets at the moment. But the point of that is to be able to, like, for all the stuff I haven't done UI for, I can just change that by hand in the project file. And then when I reload, like, I have a way to refresh the data model is the whole point without having to do UI. So I think just stuffing the whole node model into Lua and then compiling that to operators and pulling those out is going to be the easiest. But eventually I do want to keep the node model away from Lua and then instead do some like type checks and node like general graph stuff all in Rust and then pass the result of that pass into Lua. Because I think we can. But actually, the other thing is that if Lua ends up being really fast for doing a lot of those checks, I might as well also just do that in Lua, because then I can have the definitions for the nodes written in some really nice way in Lua and then have it do all the type checking there. And that's like the most flexible approach. So it might actually make sense to do that. I mean, at the end of the day, the input to this is a very well-defined model that should be really simple. Like if anything goes wrong in the Lua code, it's not going to crash because it's just going to report an error. So we're safe there. And then if it produces bad operators, that's fine too, because the compiler after this will also catch that. So like none of this will introduce bugs into the tool. There might be bugs in the way that I've described compilation for a certain graph, but that's a manageable problem. And that's kind of my problem as the author of the graph. But I think the really important thing, the key thing here is that everything is entirely like user specified and everything's entirely programmable. So I should never have to restart the tool once the system works, which I currently already don't have to do. The only times I ever have to restart it is if I make a subroutine here or a call to a subroutine and I call this subroutine and then the stack blows up, which it's in the process of doing now. That's the only time I have to restart the tool, which is pretty great. Also when I change like song files and stuff, but that doesn't happen very often. And I just need to add support for that in the tool, and that will be a lot easier once I have the sequencer. So there's a lot of things there. I'm also working a bit with this on this with Tropical Trevor. He and I have gone back and forth a lot on this design and different parts of it, and he's really keen on doing some of the UI work. So I think some of that might just happen from my perspective, but I also think that doing like a really quick and dirty UI is pretty valuable here. But before I even get to that, I want to work on some kind of data model. So right now, that's actually what I want to continue on, is this sort of prototype that I have just in this other Rust file here, where I just sort of play with the model and see what I get. So if I run this right now, all I get is the output of this basic compilation, which again doesn't actually take in any input from Rust. It's just this list of nodes, and then compiling the root of that. There's also a lot of things like I'm going to need to specify a list of Lua files that will determine the compilation. That needs to be in the project file somehow, and ideally exposed in the UI again, so I don't have to restart the tool or reload the project. Even though I could do that, I could just reload the project whenever I change that. I also need file watching on these Lua files so that if I change them, the tool will just pick that up. And right now I have that on assets, but I need to generalize that code a bit, because this Lua compilation code is not actually an asset, because an asset in the tool is something that the operator grid will have access to. So like a text texture or a shader are going to be an asset. But the file watching code that I have is all agnostic of that anyway, so it should be okay to have that as like a separate thing. And again, all this only needs to exist tool side, whereas like the asset concept also needs to exist in the replayer. I'm talking a lot about like specific implementation details of the tool, which may not make sense to you guys, so feel free to ask me if I just say something that you just have zero context for, which I would totally understand. But I'm kind of just talking out loud here too, because a lot of this is still just like floating around in my head. But yeah, but I guess the last thing I'm going to say before I start playing with code is that I'm actually really excited about this idea. I came up with it the Tuesday before revision, after feeling a lot of pain of like, I want to just have everyone else in the group be able to help out on visuals, like to be able to tweak stuff and just say like, hey, I'm playing around with the scene, there might be something here, can you try to do something with it, or have them come up with scenes and like be able to collaborate more on the visual side. Because I really felt with our last intro for revision, I really felt really like a bottleneck. I really pushed myself to do a lot of tech and to do like a lot of effects, and I think that was really cool. I'm glad I did that, but I then felt like I was super sort of blocking the intro from progressing, because like if I were tired one day or if I were trying to do some technical stuff, I couldn't parallelize anything else, where it was like Martin or Ian was just kind of there and like they could have helped out if they had this tool. Because people know how to click and drag nodes, so especially those guys. So I want to be able to leverage them a bit more. And I also felt too that like even when composing scenes myself, this just wasn't fast enough. This wasn't doing things in the operator grid, just wasn't productive enough. So, and I've known too that I wanted to abstract this for a while, but it wasn't until I thought of like, oh, I can make the compilation dynamic and put a scripting language in here, and then kind of figured out how that would work. And also, I think a lot of that took me looking at Notch and some other tools to figure out like what level of abstraction do I actually want the nodes to be at, and the answer was, well, a few different levels. So like, the compilation needs to be dynamic again. So I think that's sort of the key that got me really excited about this, even though it might sound a little bit obvious. Two Curb says, I have a bunch of knowledge and experience with shaders, graphics, and procedural generation, and some experience with composition, but I've never made a full demo. I'm afraid I'm too lazy to build a demo tool by myself. Do you have suggestions for a good tool I could use to get started? Cables, tool with, is that 2 T's or 2 L's? I don't remember. Yes, exactly what CPDT said. Those are the two that would come to mind instantly. Also Notch, but I think that's commercial only. I think Cables and Tool have free options. Dark Second said, couldn't I put a Lua node in the operator graph? And I don't want to do that, because I want the Lua to be, first of all, the Lua code won't exist At runtime, only compile time. Yes, there's also Square Melon. But yeah, the Lua will only be available at compile time, not at runtime. So, I mean, I guess if you're saying like put a Lua node in order for the tool to know which Lua files to load in, but that doesn't really work either because of the dependencies. Like I don't want to do a first pass over the operators to find the Lua nodes to then have Lua compile the nodes to operators and then do a second pass where I compile the operators. I don't really want to do that. So I'll have like some other view on it or something. The other thing that I want just to complete this sort of design here is that if I restart the tool, just so you guys can see where I'm ultimately going with this. Here we have, for example, there's similar to what we have here. I want like properties down here and then the viewport. Similar to what we have here, except I'd probably swap these actually and have the nodes down here and the properties up here. Profiler will also be down here, except I'm actually thinking of turning the profiler sideways, which is probably a better use of screen real estate. I think the Mercury guys do that in their tool. But just to give you a more whole picture, like when you select a node, you should get the node's properties. And changing any of those properties would probably cause an entire recompilation of the entire graph, which is exactly what I have with the operator grid currently, which when I profiled it was extremely fast. And I suspect that even having Lua as part of this, it will not get much slower. Because there's not going to be any threading, there's not going to be any I/O. It's just going to be very basic stuff. And maybe I'm wrong about Lua in that regard, but in that case, I can probably try and look at some other alternatives. Maybe even just integrating Lua JIT solves that problem. I don't know. Right now, I'm going to ignore it until it becomes a problem. That seems to work out pretty well. Anyway, that's a lot of talking. Admittedly, I haven't had that much time to actually sit down and like play with this code because I had to get caught up on like Wavesaber pull requests and sleep, which I still don't feel like I've done. I don't feel like I've slept properly in weeks. But we'll see. We'll see how far we get with this. Anyway, I'm excited about this idea. So I guess, again, thinking about the getting to like the very first prototype, I actually have enough here that I could probably put this in the tool. Because if I look at this, again, showing this code, I just made this basic nodes list here and just has one node here where the type name is a cube. So for example, that would be one node that could be there. And then I compile that, and that results in these operators. And the operators here that it results in is like, here's a subroutine at some position. Right now, if I output operators, I want to just output them like as operators that are way far off the screen, so you could never actually see them, and they could never collide with actual operators. Eventually, this is actually one of the reasons I want to not target the operators themselves, but then the model after that, like the AST, because then the AST nodes actually do have source information. Like there's no more knowledge that they were ever in a grid when it's in the AST representation, except that I'll just show you guys. Here, Opus, that's here, AST. This AST is, so I'll show you what these models look like actually. So this is the operators. It's just literally an enum with all these little strings. And then that gets parsed to this AST structure. And here, a lot of this stuff is kept as strings, like subroutine. The name of the subroutine is still a string. And then there's like compiler passes that are going to verify all this. But essentially, you have a node with this data, and then there's the type data here. And then they do have a position, actually. I think that's just for reporting errors. And I think I would replace this with a source structure, which would either be an operator grid position, which would have this data, or it would be a node. And then that node might have probably a unique name for that information. And that's just to propagate that through the compiler in case it has to report errors. Then it can do that with the information from the node. So that's why I want to target this AST rather than the actual operators themselves, because it's not going to be very helpful when we have if we generate some bad code here, it's not going to be that helpful that we get the error as a position that's way far off screen that we can't inspect anyway. So, but again, for the first like MVP, it just kind of makes sense to do the simplest thing, which is to just plug into an additional set of nodes, because then the compile function here, I know I'm bouncing around a lot, but that's just how my streams are, as you guys are plenty aware. The top level compiler function that compiles the operators to the bytecode, it takes in the master position, which is like the position where compilation starts, or actually where parsing starts technically. And then the operators themselves, just again, is a hash map from position to operator. These should really be U32s, not usize, by the way, but that's old habit. And then there's some predefined global variables that are available that this can do, like time and stuff. Again, it depends on what you compile the graph in, like what's going to be in this context. And that's, again, just string and data type ordered list. And then the result is either a compiled program or a compiler. So like really clean signature here. But the point is that this will make it really easy to take the operators that are in the operator grid and just merge that hash map with whatever the output of the compilation is. And that's it. Like, it should be really easy to plug this in. So that's why I'm targeting that first. I like this way of working where, like, okay, I want to implement a new feature. I'm going to like prototype as much as I can sort of in isolation and kind of figure out all the ideas, which is what I'm still doing here. And then that way you get to just sort of think about the problem itself without any of the external stuff and how it's going to fit together. And then once those things start to solidify, then you can just sort of like progressively bolt it in. And our tool, I'm generally happy with this code, but there's parts of it like the data model's in Rust, and then the UI is C and C++ because it uses Qt. And generally I'm happy with that, but there is still a cost there. When we want to change the data model, especially, we have to go through like a C API and touch a few layers of stuff. So that's also why I want to figure out like what the node model is going to be before starting on the UI. Or at least starting on a UI that's hooked up to the data model. I could do like a two-pronged attack where I'm just doing C++ and figuring out the UI, and then I'm also just doing Rust and figuring out the data model and kind of figuring out how they should work together. Have like a dummy model in C++, which I started doing with the timeline, and that works pretty well. But yeah, I'm rambling. Anyway, so I think the next step here is to actually just get this structure out of Lua now, which I've started that up here, that this would be a node, and I had like some type stuff and then a list of parameters. Right now I'm going to ignore that and just go with a node that has a position, maybe a name. I think names in the node graph will all be unique, and generally you may not need to find these. I'm not sure. Or you may not need to ever see these, but you probably can, because you might, I don't know, thinking out loud again. And then the name of their type, and then the parameters for, like, these are essentially the name of the parameter and then the values, just those pairs. And this would only represent like the ones that are set, I think. And then the node type, so like this name would look up another table which would have the types in it. This might have a parent type, or it might not. Again, so you can like inherit which kind of connectors or properties they're going to be, or parameters, I think I called them. And the properties, again, is just a list of strings and parameters, and the parameters have their own type, and the type is going to be used by the UI to expose different kinds of editors. And then a display name as well. Because the name is going to be inherent in this structure here. You have the name of the parameter and then the parameter itself. And so then a display name you would also want here, but that's separate from the actual name of the parameter. So a lot of kind of like strings just hooking this stuff together. It's a much looser sort of model than I would normally do, but again, I think that's I think it should be like appropriately weak, if that is the right word for this. In order for it to just be like super general, and then the first what am I trying to say? The first passes that go over it, make sure it's correct. Like validation passes, there we go. Validation is what I was looking for. Those first validation passes should be able to just kind of verify the assumptions that all of this is going to make. think all that makes sense. Anyway, in that sense, we would have nodes. So let's do this. We're gonna have a type name. I'll call this cube, because I think that's what this did down here, or even lowercase. Fine, we'll do that. So in this case, we have a node. It's at 0, 0. Its name is this. Its type is this, and it has no parameter set. So this would be a default node. And then the root node. So there would be a root node with most of these as well, which is, I guess, where compilation starts. So the other thing I didn't talk about is that these node graphs should be hierarchical. So like the very top level one should have like some kind of root. And I'm thinking that just like with the operator graph, in fact, I can show that in the tool as well. The operator graph has the concept of like a master position, and what that really is just where compilation starts. So in this case, is this top left corner. If I double click anywhere else, then that's just somewhere else. But I can really make this anywhere. Most cases it doesn't make sense, and if I do this in a lot of places, I'll just get compile errors when I do that. It's kind of funny actually. If I do like down here, then we don't get the aspect stuff, because that's actually done in the operator graph. So we get the whole width of the viewport here, whereas that correction is actually done with this first part of the graph. So that's kind of fun. But my point is that like for the root, I just want to have just some operators. Then you can just kind of have a way of picking which one is the root. And then again, the connections are going to determine how all that fits together. Yeah, it is going to be a lot like blenders. And also, I mean, that's another use case is what if I want an entire graph type for doing materials? I should be able to do that with this as well. Generate shader code from that, for example. It all makes sense in my head. Just a matter of making it work, seeing if it's actually useful. Okay, so in this case, I think I already have this stuff where it goes into Lua just from that basic thing. But then we need to actually pull this out of here. So this is pairs nodes. Does that actually make sense if I just do... If I do this, for example, I might be closer to getting this working than I realize. I'm going to do this again just to be sure that I have that in there. Just run this. Nil index value, probably because... Actually, why is that? Oh, probably because I indexed it from 0, but I need to have like the root name. So I'll do that as well. Just root node name here. And then I'll set... Okay, so I actually set root node name. So then in here, I will do this. Call a nil value. So I really need to pretty print these errors. But for now, it's fine. I also want to type name. That's probably actually what happened here. Set. If I remember how to type. Probably actually the problem. There it goes. Cool. So that works. We just compile the node. And if we look at the output here, there's a subroutine at 1000, and that's called scene. And then here we do, that's like what's actually being compiled around this code. And then here we have what our cube actually represented, which here is the op subroutine at 1001. And I called it some sub. I actually want to use the node name for that. So if I do, actually, do this. Local name is node.name. Oops. I'm not that familiar with Lua, by the way, so it's going to be a little clunky when I write this, but I just have a feeling that'll work itself out. Like this. And if I were to run this, then I think we get Testy Boy. Yes, so this actually creates a subroutine called Testy Boy, which is actually empty. And then it creates a subroutine called Scene, where its only operator is calling Testy Boy. So already, like, this is a useful graph. If I had... so again, it only compiles the root, so we need to do connections here somehow. So if I wanted to do another one, which I think it's like exactly what I had before, let's put this in a different position, even though it wouldn't have to be technically, because these aren't actually used for anything. It's these names that are going to be used for the nodes. That is still, yeah, so it's found here in the nodes, but of course it's not compiled because like these aren't connected in any way. So I think actually we want something like this. Node name, call this root boy. And I don't know what type this would have. I don't know, let's call it scene. So it's actually root boy. That's going to be our root. And then we can do compile root here. Get rid of these dummy nodes. And yeah, we can actually do this as well. We can take this from this. See, already we're seeing patterns here. Chocolate Trevor, how's it going? It is YX. That is actually the name, or the secret to comp winning demos. Very important. Oh, are you in Japan now? What time is it there? Type name. That's probably because of this. It didn't know how to compile a root. Actually, we should do this compile node here. Thank you for saying that, Wax. I don't think anyone has pointed out to me those names except CPDT when he asked me, "Oh, is that what small squish means?" Yeah, it's actually funny because on master on the squishy repo, I have like a lot of debug information, and then I have a branch called Baka, which has the which has the output that all of you guys see. So. I think that's fun. Big squish and the small squish. And what those are in Squishy is the big squish is it squishes your code and then some like unfiltering stuff together. And then the small squish is it links all that together and then squishes the decompressor. So yeah, the Wavesaber ones are always fun too. The Wavesaber device names started with like, what's the most 80s? Like if Wavesaber existed as an 80s cop drama, what would all the synths be named? And that's why like Falcon and Slaughter and all that stuff came. It just kind of fit that, I think. And also the name Wavesaber. And it derailed from there at some point, but that was the original thought. And I think that's fun. Yeah, that is actually why it's called that, Maxlow, because it's technically cheating. As Ian came up with that one, I think. It's dumb. Anyway. Oh, that's great. But yeah, compile root here. What we actually want to do is we want to compile the children. Give the node the context. Yeah, Huffman has great commit messages. Unfortunately, a lot of that stuff I end up squashing away in the actual history now. But in general, they're pretty great. By the way, hi. But yeah, I'm actually getting pretty satisfied with how this code is going to look, I think. I think this is where things already start to get interesting, because I don't want necessarily the nodes to have a concept of children. I want them to have a concept of connections, and the connections would be like a connection to another node, but I want that to be like typed. So sometimes I want that to be like it can only connect to this kind of node, and maybe it can only connect to 0 or 1 of that kind of node, or it has to be connected to one of that node, or it can be connected to 0 or more of those nodes, or 1 or more, for example. And so those kind of traversal rules are going to differ per node. In this case, instead of trying to find out the abstraction, I should just do the code here. Yay. Where it actually is going to look for those connections. So what I'm going to do is let's add some connections. And we'll get those into Lua somehow. I'm really happy I'm just playing with this in this little test bed. I think we'll pretty clearly see that this is going to work. So it might actually be 2. That maybe the connections are encoded just as other parameters. I'm not entirely sure. Because you need sort of like connection points for this. So it's like connections is some kind of map from string to something. And this might be not sure. Because also the parameters themselves too, you might want to expose those as potential connections also. So it might be that the parameters themselves also encode connections. And in the case of like a node, its type might be a parameter, and then the type of that parameter might be like a list of nodes of a certain type. And then the only way that you could satisfy that is by connecting it to other nodes. Whereas another parameter might be like a string, or I mean like a float with potentially like a min and max. And then the way you'd expose that is probably like a slider, something like that. Yeah, tuples of unique IDs in a list would be enough. Definitely would be. And in fact, that's also enough to encapsulate these other parameters. So like, I think I'm going to stuff that into here for now, and we'll see if that sucks. Because again, that would allow you to both, for example, for a float parameter, it would allow you to expose it in like a list of parameters. Additionally, it would allow you to connect that to a node that would represent a float, and then maybe that can branch out to like a little expression tree, something like that. Hey man, Triangle, I'm working on some higher level node abstractions for the demo tool. Still kind of in the prototyping phase at this point. But yeah, I think we'll just call these all parameters now. Maybe properties. For some reason, I like the name properties for this. And that's still distinct. So like a node has properties, and that's distinct from an operator, which has expressions. And I like that distinction because there's like a couple stages of compilation that are going to be in the tool. So it's nice to keep those as separate as possible. Mad Triangle, this is not what I do for a living. It's what I used to do for a living, actually. But not anymore. Now what I do for a living is I write assembler for artificial intelligence accelerators. I can't really say much more than that. But I write assembler that runs on artificial intelligence accelerators as part of building big systems. Anyway. I just started doing that like last month, so still new to that, but very much enjoying that job. No, not GPU assembly. IPU assembly. So actually very similar, but also not. The name is GraphCore. It's on my Twitter. I'm not hiding that. GraphCore.ai if you guys want to check that out. Yeah, Skynet. But yeah, so the nice thing about this is that we don't actually need to give properties a type. Or I mean to do the connections with anything other than these properties here. So if we do, I want to connect these cubes, so we'll connect this first one. I'll just comment this one out for now. In this case, it would be this property here. So this might have, for example, this is the easy way to do this in Rust. Make a tuple here, and then we'll do this. CMXO. So we'll do, for example, children. And then testy boy. Oh yeah, into iter. Just do it. And in fact, we'll just call this subject for now, and we'll work on how to make that like children later. Node dot properties, and I guess we can just call this subject. We'll do this. Compile node. Like that. The context. This is pretty cool, actually. I like that. The next thing we need to do, though, is make sure that we actually have stuff in here. Make sure we actually do these properties. So, easy way to do that. Let's equal to context.create table. Then we can do nodes table, no. Node table dot set properties table. Hey, disused. Yes, I'm doing streaming again because revision's over. Fancy that. I'm hoping, not committing to anything here, I'm hoping this tech will work by Sulsguin and we can throw something together pretty fast for that. We'll really see though, because also would love to chill for that party. But I also feel really shit if I don't have a release, so I'll figure something out. But Hoffman's coming, so that'll be awesome. Yes, Mad Triangle, this is to make demos. This is expanding on the tool that I already have for making demos by adding some higher level, more abstract stuff. I know I'm leaving out a lot of context, but at the same time, it's like... I already kind of explained this earlier in the stream. So I don't mean to leave you out of the loop. I just kind of got to keep going here. I have a lot of streams on that, by the way. Yeah, no worries. No need to apologize. No need to apologize. So for this, we just need to do for, I guess, key value in node.properties.iter. And then this should be really simple. .set. And we'll do key.clone, value.clone. I won't make it to Datastorm this year. Not this year. As much as that's an awesome party. Not making that this year. I'm going to add more debug printing for the properties here. Pairs node.properties. And then we'll do name value. That should at least make sure that we're getting this here correctly. And we are. So we got that, which is great. So then, what would this nil value be? It's annoying because it's like hard to translate this. I should have this in a separate file, but I'm just not there yet. Where it would be a lot easier to figure this out. What the actual line here. In fact, actually, since I'm just running this anyway, I might as well shove this in a file. And then Sublime should figure out that this is Rust. Or not Rust, Lua. There we go. By the way, thank you guys for the new followers. Is that how you say that? I don't know. I've been missing that this stream. I'm sorry about that. So we can call this, put it here, test.lua. I wonder if this context load takes a path. That'll probably interpret it as source. I'm just gonna look at the rlua API to see if I need to load this from a file or not. Because I'm gonna be lazy. Yeah, I'll just read a file into a string and do that. Oh, that's actually great to see use. Yeah, that's a great use for that. Thanks for the tip there. That's actually perfect for that. Include string, and I think you do it like that. This probably needs to be in source now. That's fine. We can just move it in there. That's a good call. Botch. So now when I run this, do I need to recompile the code? Yeah, include string, include bytes are awesome. Because I thought that this, like the dependency here actually worked properly now. Otherwise I'll do one of those dummy things. I thought this worked now. We can test that. So here it just finished like immediately. Whereas here, yeah, they're actually rebuilt. Yeah, so actually we don't have to worry about that, which is nice. I do recall that being the case at one point, but I think that was fixed. Or maybe I'm just making that up. Anyway, thanks for the tip. Glad we checked that. That we know for sure. Anyway, the point of this is that this will tell us 104. So 104 was here. Node type name, it didn't like that. Wonder why. Maybe if node was nil, that might do it. So if we look at subject, this testy boy, which we should have here in nodes, we can do some printing here. That'll make it easy to debug. Don't think that worked. Why wouldn't that work? Seven. That's still here? It is. We can do this too. Scene. Oh yeah, because I changed root to scene, didn't I? That's an easy change. Yes, now we get it in 90, which is here. And that might have just been concatenate table value, which is fine. There, it worked. Beauty. This actually rules. So now we got the root boy, and it made the testy boy thing here, which is cool. We can go back here. I scrolled up, which I don't need to do anymore. Traplaw, thanks for the follow. Cosmo, how fast is Rust at compiling big projects? Not fast. Not fast. Luckily, we're working on a small project here that we will integrate into a big project. And those compile times are pretty transparent right now. Also, that probably got a lot better recently, and I just haven't noticed. Yeah, so now we need to come up with a way to, for example, encode multiple values here. We could do this a couple ways. I can imagine like maybe I do an ordered list and we parse the list in Lua. That probably wouldn't be too bad. Perhaps I allow this to be like multiple values for the same property. Maybe that's how the connections are represented. I don't know how that would really look to the Lua side. You know, I think what I want to do here is we can have a property type here. Or some value type. And we could do, for example, string with a string. We could do string list. Because then maybe we would pass it to Lua as like an object with like a tag and then data, and then we would interpret that data differently. And then already, again, we're sort of working towards this model where we get some checking on the Rust side to make sure that things can actually make sense. Still not sure how I want to do this. Hey, Soda. You know, I think what I want to do actually is this and do a comma separated list. Because I think that might just be the easiest for now. Hey, Trey Guy. Yeah, Lua does have dynamic types, but we need to still determine what the type is based on the property type. So adding a tag kind of makes sense. And then we rely on the fact that it's dynamic typed for the data part of that. That's sort of the union. I don't think I want to keep this moving forward, but for right now, it might be a good idea. Or maybe I'll sit and think about it more. I think I actually want to tag it because that's easier for Lua to parse it actually. Yes, the name subject here totally doesn't make sense now. You're absolutely right about that. Since this is a scene I want to call, I could call it connected to, for example. I'd rather call it, because the scene might have additional properties, especially like for different parameters on the render. So I'm thinking that I'd want to call this maybe even subjects Whatever you'd put in a scene. What's the contents of a scene? Contents, maybe. Kind of like that, actually. Yeah, children also isn't that bad, but I'm not really sure. Now you're thinking with Dom, exactly. Maybe that is actually something that's familiar. I don't know. Scene boys. CPDT did it. You know what? I'm just going to call them the boys. We can also add some bevies. Yeah, it's definitely going to be called the boys. Yeah, the other reason I want a description of which nodes are going to exist in the graph, in addition to being able to do some like basic validation before we ever get to Lua. Exactly, Luna. In addition to that, I need to be able to like have a palette of which nodes are available for given like node. I'm so bad at talking today. A given like node graph type. But for now, it's all just strings. It's all just strings. Yes, these are the parameters, which again are going to be called properties. And here again, this model actually makes sense. Properties and then a property value. Yeah, this actually does all fit, doesn't it? Properties have these types and the values as well. The node type will have a list of property values, properties and their values, and the properties will have lists of which ones are actually set. So you would have a property gets a property value. This actually does make a lot of sense. So we actually will go with this. We'll do string, again with the string value. We'll do node list with a B-tree set of string. I like to use like B-tree set and B-tree map because it maintains the order, which typically it isn't an actual constraint of like getting the data correct here, but when we start, if we start debugging this or reporting errors and stuff, it's just better to have these in order. Also with serialization, because it should make the diffs better to have some kind of deterministic ordering for these. Otherwise, like every time you load and save a project, which we generally put in Git is why that's important, they're all going to be out of order, so we'll get a lot of extra stuff in the diff. So yeah, I actually really like this now. So now we get the boys as property value node list, where we have this, and for this we'll just do this. And the type inference solves all our problems. Thank you, Henley Milner. I have no idea if that's the scheme used here, but anyway. So now we set the properties. We gotta do some stuff. So we'll do this. Let property table. Lots of table nesting here, but most of the like pulling data off of that is going to be encapsulated within functions in Lua, so that'll be really nice. And like this is literally all the code that it takes to inject this entire model in here, so pretty good. And to extract it's even less. That I like. Yeah, anyway. Let's see. I don't have any plan for project file merges except make sure they're in textual format and the and everything has deterministic order and hope it works out. We'll have to see if that actually becomes an issue. So I don't have a plan for that, I guess. So far on my own branches, it hasn't been a problem. But I suspect it might be when we actually start doing merging. We'll see. Anyway, this we want to do match on the value. So we'll do string for now. Rust, at least to my knowledge, doesn't have any way of doing of specifying most collections actually. So like a B-tree map or B-tree set. I don't think it has macros like it does with Vec. So I made a vector here and then turned that into an iterator, which is an iterator over all these values here. And then I collected that into a B-tree set here. And the type was inferred because of this. The context is that we're constructing a node list. So that's what I meant by that trick. Just I didn't have to type any types. And maybe I'm super out of date if there are macros to build those other collections, but they're not something I'm familiar with. And then we'll call this nodes. Actually, that's fine. Node names, we'll call this. Or just names. No, we'll do node names. Yeah, exactly, tray guy. Nothing fancy. So here we're gonna do property table dot set, and we'll do tag. We'll even call this node list. Let's do strings for this. That's probably crap, but it's fine. Thanks, Aaron the German. I am roughly, but I should actually be more hydrated than I am right now. Hydration is very important. That is what I want, by the way. And then we want to go through the names here. So I think instead of just having like a data and fanning that out, I'll just add, well, actually we'll do this. Let names, node names table is context dot create table again. And then we'll do property table dot set node names to the node names table. Good. Then think we can do for, let's do this. I name in node names dot iter dot enumerate, and then we'll do property table dot set, and we'll do I+1 because Lua, and then we'll do the name dot clone. This probably makes sense. Now, before we get any farther with this, I want to bring this back. Do that too. And we'll do we'll do it here. Value dot, what did I call that? Tag. Start with that to make sure we get that correctly. Node list, boys. That makes me happy. Great. And then we'll actually check the tag. So is that equality in Lua? Probably. Again, I don't know Lua, but we're figuring it out as we go. And this is going to be just the different names. So I guess it's for node name in, I hope this shadows properly. We're about to find out. Can we just do this? Like this? I don't know. Then expected near due. Then there we go. Nelson 4K, thanks for the follow. Don't think that was correct. It wasn't. Hey, Mad Moose. Is node names the right name for that? Oh. Wait, is this... That should be the right syntax. I would have thought, let's do, just to be sure of some stuff here. Call this N. Case that doesn't work to shadow that. Don't think that's the issue though, because I think it would have printed something. Also, we're getting these in different orders because I guess as we put these in a table, that ordering isn't preserved, and that's fine. I don't really care about that, except actually we will care about that in this case. So actually, pairs isn't what we want for this. If you want to iterate over a list, I gotta look up how to do that in Lua. I mean, I think we can do. Yeah, I pairs, we have that too, which is actually probably what we want in this case. So it didn't quite work though. Let's try this. Let's start with that, actually, just to make sure it prints high, to make sure that conditional works. And it does. So then we'll do this. And I think it's hash. It's 0, which is crap, because that should be this. Maybe this is nil or something stupid. Okay, I need a table value. So it's not nil. Oh, that would do it. Set that on the wrong table. Ha! There we go. We got Testy Boy. I'm enjoying this, you guys. So let's more or less copy this. And we're just going to assume the type here. So we probably didn't have to load that tag anyway, which is fine. We'll do boys.node names. In this case, we're going to do this. Yo, did that work? I mean, it must have, because we got Testy Boy there. So if we go back in here and also add other boy. Nice. That's really cool that that worked. Except it didn't preserve the order, which is crap. Why didn't it do that? Because node list should have gone. Oh, it's probably because of the. This is totally the wrong collection to use this, I think. A B tree set of string. I mean, that's nice to keep that unique, but this actually should be ordered. So let's just do this. And then I think that's where we lost that ordering. There we go. Now it works. Cool. So effectively what we've represented now, very simply, is this. So this is our root. And this is called root boy. Root boy. And it has the boys represented here as boys. And this will be connected to the hip bone, a Testy Boy, and the other boy. Noodly. So we've done this. We've represented this. And what we've compiled that to is a subroutine called scene, which calls Testy Boy, and it calls other boy. And then we've represented a subroutine Testy Boy and a subroutine for other boy. And I don't think these do anything. So I think we've compiled it to this. Which is what we see here. That's actually really cool. Really cool, actually. So if you wanted to change, like right now, it just starts and ends the subroutine. But eventually we want to do like locals and stuff. But eventually we want to do context, call, default cube. So imagine just now when I edited this, that it just recompiled the graph and now we had cubes in the scene. That's the workflow I'm imagining. That's actually pretty sick. So I think I might have fleshed this out enough to start putting a first version of it in the tool, actually, which is rad. But I won't do that today. In fact, I might do that early next week. I'll definitely continue working on this next week on the stream. And I might do some stuff in between that. We'll see. But I think this will work, and I think this is actually pretty cool. I think this is going to be a good approach. It might be dog slow with all the like string cloning and stuff, but I suspect it won't be. Because we already do a fair bit of that in the compiler, and that doesn't matter. So yeah, and actually while I'm here still, we can go ahead and, well, actually I do want the tag if we want to check this, so we'll leave that on there. Anyway. Neat. You can tell it's an aspen tree because of the way it is. Isn't that neat? All right, I'm going to go. Thank you guys for hanging out. And I'll see you next time.